change this, 9.2. Okay, so 9.2 we're going to talk about another way to solve a quadratic equation. And that's just the quadratic formula. This is kind of the end-all be-all of solving a quadratic equation if no other way works, which shouldn't be the case because you can always complete the square and turn it into a square root property. But if you don't like that method and you want to use a different method, the quadratic formula will always work to solve a quadratic equation. And there's not much algebra to do. I'm going to give you the formula with your a, b, and c value, and you just substitute them in and evaluate. So in order to use the quadratic formula, well, let me write down the quadratic formula first. So the solutions to a quadratic equation of the form ax squared plus bx plus c equals 0. So notice, when I'm going to use the quadratic formula, it has to be in standard quadratic form. It has to be equal to 0. So this one's happy. Right, this one, we got some work to do to put it in quadratic form. Right, so we're back to standard form here. The solutions to the quadratic equation of the form are given by x equals negative b plus or minus the square root of b squared minus 4ac over 2a. The whole thing divided by 2a. It's not a pretty equation, but it definitely gets the job done. And I don't have really any steps to finding our solutions, but I'll kind of box this up. This is the important part here. Right? So first, put equation into standard form. Substitute A, B, and C, and evaluate. Right. Sometimes there's going to be very little to do to evaluate, right? Depending on what happens under the square root. If whatever comes out of the square root piece doesn't simplify, then there's not much work to do. But if we have to simplify the square root, sometimes this could be negative. We might end up with imaginary values. But really all the simplification usually comes from the square root piece. But other than that, we're just plugging numbers in to our formula and popping values out. All right, so let's just jump into a couple examples. All right, so our first one is already in standard form. So I'm just going to go ahead and identify my a value is the coefficient of x squared. My b value is the coefficient of x. It's not x. None of these have an x in them. It's just the coefficient. So my b value is 1, and my c value is 2. So the solutions to this quadratic are going to look like negative b, so negative 1, plus or minus the square root of b squared minus 4 times a times c, all divided by 2a, 2 times 3. And from here, it's just a simplification. If you have a nice calculator, most calculators can do all of this for you very quickly. You can even plug in the whole expression into your calculator, or you can do it little bits at a time like we're doing mentally here. I know 1 squared is 1. 4 times 3 is 12, 12 times 2 is 24, so minus 24. So this is going to be x equals negative 1 plus or minus the square root of negative 23 over 6. And the only simplifying that I can do here is this negative under the square root. We tend to not like to leave that there. So that just tells me that my answer is imaginary. And we've got our answers here. No simplifying left to do in that case. All right, and notice our answers come out looking a lot like the way they did with the square root property. All right, it's just another way to get to that end game. All right, and if you looked at a proof of the quadratic formula, to prove the quadratic formula, we complete the square with the a, b, and c values that are there. So it's just a way around completing the square, essentially. All right, for number 2, we have a little bit of work to do to set up the equation in standard form, but once it's there, we'll pick our a, b, and c and run with it. So we can distribute x squared plus 5x minus 2 equals 5x plus 2. So I still need to get it in standard form, so I need it equal to 0. So I'm going to subtract 5x, subtract 2. So we have a 0. X squared minus 4 equals 0. Right. And at this point, hopefully in this class, x squared minus 4, you look at that and you say, that looks very factorable. And you're right, it is very factorable. And if you notice that, you can do the problem by factoring, but if you want to get in the hang of trying the quadratic formula, just to show you, the quadratic formula works in every scenario. So we can always use it, but factoring is definitely the cleanest, most efficient way of solving a quadratic if it's possible. So right here, I'd say factor and solve. But for the sake of the section, let's use our quadratic formula. And this one's good to notice. Sometimes you might be missing a value. Now we don't have our x term in there, but I still have a coefficient of 1 for x squared. I don't have an x term, right? There's no bx term, so that must be a 0 for b. And my c value is my constant of -4. So that means in the quadratic formula we have -0, so this is 0. We'll just go ahead and write it, plus or minus the square root of b squared, so 0 squared, minus 4 times a times c, all over 2a. So I don't need the 0, we just have plus or minus. And that would be the square root of -4 times -4 is 16 over 2, which is going to be plus or minus 4 over 2, and that's going to be plus or minus 2. Right? So it worked out nicely. We got 2 very clean answers of plus or minus 2, which would have been the same thing, just as a side note. Okay. Since I did say factor it, what would have happened if we would have taken this and we would have factored it? Well, we would have ended up with x plus 2, x minus 2 equals 0. And then from each factor, we can tell our solutions. This one gives me an answer of -2. This one gives me a solution of +2. And we can see that our 2 answers are plus or minus 2. Clearly factoring the more efficient route and the cleaner route, but quadratic formula still gets you to the same end result. So always will work. And that's pretty much it for the quadratic formula. Sometimes you will be missing a b value or maybe even a c value, but that's okay. Also, since it is an equation, if there's ever one that has any fractional or rational coefficients, right, we can do the same trick we've been doing all class and multiply the whole equation by the common denominator to cancel out those fractions, so you don't have to deal with fractions along the way in the quadratic formula. So, all right, keep in mind those tricks, and using the quadratic formula shouldn't be too bad.